speaker on air pollution control technology, Arijit Mallick. Arijit,
Can you hear me, sir?
please.
Yeah. Good afternoon, everyone. So today I'll talk about my material is the metal organic frameworks that will be useful for the CO2 capture from air to control air pollution. So as you know, I will start with the data published by the World Health Organization, and they have estimated that around 7 million deaths per year it happens due to the air pollution. And because the 80% people are live in the urban area, and in urban area the work quality index is generally higher than the permissible limit. And if you see the map below, here we can see the pointer. Here you can see the black area where the Southeast Asia, especially India, Taiwan, this region are mostly affected, and they have estimated over 2 million people will be affected in that area due to air pollution effect. So, the carbon dioxide is one of the greenhouse gas which affect the air pollution as well. And my work is mainly focusing on carbon dioxide capture. So, as you know from the Charles Killing, the Killing curve, and it has predicted, and we can see the amount of carbon dioxide is increasing in atmosphere day by day, and it is having a huge effect on our environment. And scientists, they have predicted that if we don't control this carbon dioxide emission, it can have a massive effect on our environment, and it can lead to a mass extinction of human society. And from the prediction, you can understand that the rate we are emitting CO2 nowadays, if we don't control in 21st century, it will be a huge irreversible effect that we cannot control. Okay, so what we need to do? What was the solution? The solution will be we need to somehow capture the carbon dioxide. And to capture this carbon dioxide from either from the industry, means from the source, or directly from the atmosphere. So capturing carbon dioxide, we need to develop some technologies. At present, in industry, people are using the liquid amine-based technology. And this amine technology, the amines are highly toxic, corrosive, and also they react with carbon dioxide chemically. So to again get that carbon dioxide back from the material, you need to heat the material. So you need to have more energy. So the total cost of this technology is very high. So what will be the alternative? So in that case, we are giving an alternative technology using some porous solids. So in porous solids, instead of carbon dioxide bind chemically, they will bind physically. So during physical adsorption, the process will be more easier, and it will be cost effective. So there are different porous material in nature, but in our focus will be on metal organic frameworks, because it will have the desired pore size. We can control the functionality and everything. So what is metal organic framework? Metal organic frameworks are also a solid porous material. And if you see from at molecular level, it will have a micropore. And if you have, and it forms via a reaction between organic linker and metal ion, and that will give a three-dimensional structure which have nice porosity. So this inside this pore, either you can store the carbon dioxide, or you can also selectively separate the carbon dioxide from other gases. So if you see in this animation, if the carbon dioxide emit from the industry, that can actually trapped inside the pore of this material. So that is the beauty of this type of material. In lab, we have synthesized one of the benchmark carbon dioxide capacity material that we have given the name Coast 7 material. This material have the highest CO2 affinity towards with compared to the other gases, and this material shows very good CO2 carbon dioxide capturing ability. So even you can see the carbon dioxide can be visualized seen by via a different characterization technique. This inside the pores, the CO2 molecule are trapped. So this technique we have by using this technique, we need to now synthesize this material in bulk, because in lab we can synthesize material in some milligram. So you can see in first reaction we got around 250 milligram of materials. So but if you are thinking to synthesize material for the industry, you need to make the material in kilos. So it took around 3 years to completely find out new reaction method where we can now make the material in kilogram scale. So you see in lab, we can synthesize this material with 50-liter container, and we can now, we already made over 100 kilo of material. And this in industry, this material can generally packed in 2 different columns. Okay, and this column will help to separate the carbon dioxide from other gases. So yeah, that's why when we try to pack our material in column, so there will be 2 problems. So the main problem is that if you pack the column with pure powder, then what will happen? If you flow the gas flow will be obstructed, because the column will be completely packed. That's why you need to make the material in some shape, okay, like granules, some beads, or some pellets. Okay, so in that case, we have added 5% of a special polymer, and this polymer bind this material and give a particular shape. And you can see it is now our material are in can be nicely packed in a column, and that will also allow the flow the gas inside the column. So we have did the measurement, and we have seen when the column is fully packed with powder, the pressure is dropped drastically. But if we pack the column with our shape or bead material, we'll get very nice separation of carbon dioxide. Now, after that, since our material is showing very good carbon dioxide storage capacity, now we need to think that we need to make a prototype instrument from where we can directly capture the carbon dioxide from air, and we can store into the material and then again release that carbon dioxide and capture into some cylinder. Then that will be useful for other purposes. Okay, so we made a first prototype. That actually this prototype was made in Saudi Arabia, where I was working before, and that was the first prototype where 3 kilo of metal organic framework was stored into that instrument, and we got around 11 ton CO2 per year capacity. Then we made another advanced machine, the prototype 2, where we can store more amount of material. So, and now I am here in JNU. We are also now planning to make another prototype where the capacity will be more high. So the beauty of this prototype instrument, or you can say this carbon dioxide capturing instrument, is that if you can install this instrument, that can actually capture CO2 more efficiently than trees. So you can think about the direct air capture unit, whose capacity is 1K ton, so which is similar to the 50,000 tree. So in a one room, in a one room where you can install a machine that will be similar to 50,000 trees. But we know in every year 50 billion tons of CO2 is releasing in the atmosphere. So we need to install more and more and that type of instrument, and which is more than 1,000 or lakhs instrument to capture the CO2. Otherwise, we cannot control the goal where the earth temperature need to be controlled below 2 degrees Celsius. So if we see the global status, the direct air capture unit mainly leading countries are mainly US and Canada. And in Europe also they are also installing this type of units, and they are doing some development in that area. But if you see in Asia, especially China, Japan, and Saudi Arabia, they are developing some instrument. But especially India, Taiwan, this region, the technology development was very slow, or you can say that there is no unit has been reported till now. So we need, as we know from this the data, our region, especially the Southeast Asia, will be more affected by air pollution. So we need to have develop this type of technology in our country, and especially Southeast Asia. So we can conclude that we have made some material that have the capability to capture CO2, and we have also made some prototype instrument. Now we need to develop this type of prototype instrument in our Southeast Asia. So I want to acknowledge JNU and the School of Environmental Science, and also the seminar organizer, Asian Oceanic Geoscience Society, for giving me the opportunity to deliver lecture here. Thank you.
Thank you very much, Arijit. You are requested to send your paper to Professor if he has given his email address. Please send.
Okay, thank you,
Thank
sir.
you very much making this